Now we have already made the layout of a NAND gate. Now we will make the layout of a NOR gate. So we'll first open electric, adjust the windows, window, tile horizontally. Okay, now a new library saying NOR gate. This will include my NOR gate. Yes, it's present here. A new cell schematic NOR. Now, like in NAND, PMOS were in parallel. In NOR, the PMOSs are in series. So we will use two PMOS in series, two NMOS in parallel, a ground, a power node, two off-page nodes for the input and one for the output. I'll just flip this. So I'll go to edit, mirror, left, right. Now we'll make the connections. For the output, input. Now we will change the width to 10. Okay, I will export these nodes first. So I'll use the shortcut Control E. And to say A or B, I'll say A plus B. Or I'll rather say A or B. Yes. Now we are left to set the spice model. So we will click on the device, tools, simulation spice, set spice model. I will use the shortcut key. PMOS, PMOS, NMOS, NMOS. Okay, now I will check if there are any errors. Yes, it says 2 errors. What are they? The arc dangles. Okay, let me see. This is proper. Oh, there is no connection. So I will delete this arc. Left click, right click. Yes. And it shows me the presence of some more pins here. Let me just check. There are no errors. But just for safety, I will go to edit, clean up cell, clean up pins. Yes. Now the schematic is ready. Now let us write the spice code. It is the same as that we wrote for the NAND gate. And now I will simulate it. Let's check. Plot settings, add plot plane. AP. When the input is 1, 1, output is 0. For 1, 0, output is 0. For 1, 0, output is 0. For 0, 0, output is 1. Yes, it works fine. Let's check the log. It says the measurement failed. The measurement has failed because here I had said the input is AB, whereas my input is A, capital A or B. So I will just insert an OR. And I will run again. And check for log. Yes, I got a fall time and a rise time. It says it is from 12. 12, yes. And it is rising somewhat at 135.5 somewhere. Yes, we can say so. Okay, so we are done with the schematic of a NOR gate. Now we will make a layout. To make a layout, like you can see, the two NMOS are in parallel. Whatever structure we had for the NAND gate will be just kind of reverted for the NOR gate. Like, let me show you the earlier one. In the earlier structure, as you can see, these two PMOS are in series and these two NMOS are in parallel. So now we will have two NMOS in parallel and two PMOS in series. Remaining things will be same. So let's start making. I will make a new cell. Say cell, new cell. But now while making, I'll make sure that the library it says is not NAND but it is NOR gate, so that there is no confusion. And I'll say NOR. Now my cell has been correctly formed in the library NOR gate in the cell NOR. It is not in the NAND gate. Now let's begin with the layout. We need PMOS, NMOS. Rotate them both, or you can just press Ctrl J. Copy them using Ctrl C and paste them beside. Ctrl V. Okay, now we need the contacts. Like we need to take connection from the particular drain or source to VDD or to the other transistor. So we will first look at our schematic. Our schematic says that the two NMOS are in parallel. So we need three contacts. One for this particular NMOS, one for this NMOS, and one contact which connects both the NMOS to the PMOS. So we will use an active region, and one more here. whereas for PMOS we only need 2. So we will use P active region 1 and P active region 2. Now we need the source and the VDD, right? So we use an N well as the source and a P well as the VDD. Let's make this size also 30. X size I'm saying, because this will be our VDD, and the ground too becomes 30. The transistor's width has to be 10. And the contacts also have to be 10, but the Y size have to be 10, not the X size. Now you can see that these are not aligned, so there might be some connection errors. Let's see if they occur. Okay, left click, right click, left, right. Left click, right click. Make sure that when you left click this, you left click on this particular portion and not here or at the center. Yes, now bring them closer. We got this error previously while making the NAND gate. But as I said earlier, you can ignore when it says error for the particular transistor when you are moving it. Bring things closer. Yes, if you want to select the entire, like you want to select the contact and the PMOS together, so you have to draw a box around them and then move any, all of them will move together. I will just put this close enough so that it doesn't show me any errors. Let me check if there are any errors as of now. Yes, there are 2 errors. It says the contact and the region is a problem, so we will just delete that region and we will make a contact again. Oh, the problem was, let's see, solved or no? Yes, it's solved. So now we have our skeleton ready. Now I will join the drains, the polysilicon gates together. And now one is connected to VDD. This terminal is connected to the center and these 2 are connected to the ground. Now I'll just move this up, not this, the metal. Let's check for DRC. Okay. Now let me name it. To name, I won't double click. I will export it. Please do not forget to export. VDD. Ground. Now we'll use the contacts. So you can just left click, right click in between, right click again, left click, right click. For metal nodes it won't show a problem, but metal contacts. But when you are connecting two different layers, yes, it might show some errors. Make sure that you're checking for DRC errors every now and then, so that they don't pile up at the end, and you can sort them easily. Yes, done. Now I will name them B. I just undo that thing because what I changed is the name of the contact, whereas I wanted to export the contact. This is my cell, my input, so I'll just name them as I want. Export, and I'll say this is A. Export, I'll say this is out. Okay, I think we are done. No, we are not done. We did not set the spice model. So select and go to Tool, Simulation Spice, Set Spice Model for all the devices. If you aren't able to see, just zoom in, Control and click. NMOS. So we are done here. Yes, now we will check for the well errors. There are no well errors since we have named both, and both regions are merged together such that they are touching, but the two regions have well spacing between them. Now we will go for NCC check, that is schematic versus layout, and it shows us some errors. Here we have 3 ports, 3 parts, yes, 5 wires, 5 ports. Now exports. Exports is the problem. What it says, there is an export in the schematic named A or B, which is missing here. And it says VDD, which is implied in the schematic. It is not present here, but we have something known as VDD. Now the difference between this and this is that the V is capital. So we will first delete this and export it again, and this time keep it as small VDD. Let's check. Yes, 1 has decreased. Now the problem is between A, B and out. So what will I do? I will just say control click. I will delete this. I want to change the input. I want the right side one positive and the left side one. Sorry, I want the right side signal as B and the left one as A. So I will just delete this. Say control 9. I am going to export this node now. Export, create export, and it is A or B. I will export this as capital A and this as capital B. Let me check tools, ERC, NCC. NCC check is complete. Now if I say just interchange, I say this is control E, B, and if I say it is A, and now go for an NCC check, it will show an error. What is that error? It says that one is connected, other is not, which means this shouldn't be going. The terminal, the transistor which has the B terminal shouldn't be going to VDD. Instead, the transistor which has A terminal should be going to VDD. So we just change the terminals. Now let us see if our schematic works. Sorry, layout works. I will just copy the code and paste it and simulate. A, B, A, B. Yes, it does work. I use a shortcut. It is the same. Let's check for log. It will again say fail because we did not edit. Now if we run, yes. Now just observe the rise and fall time for an input of the schematic and rise and fall time for the layout. But you can make, say, icon views. Like we made the icon view for NAND gate, we can make an icon view for NOR gate. I will show you how to make an icon view. We will go to view, make icon view. We don't want a box, right? So I'll just delete this box. Let A and B be where they are. Let me shift A or B. Now for this particular thing, all I need is an arc. So I will use this. Now like we used the earlier tool, which was this, which was an opened polygon, but it was like it always moved in straight lines. This on the contrary will move in curves. So we will just select this particular thing, edit, modes, edit toggle outline. The shortcut is Y. And I will just adjust this particular thing as per the layout, the diagram of an of a OR gate. Yes, does it look something similar? Okay. Change the cursor. Now one part is ready. What will I do is I will just copy it and paste it down here. Control V here. And I will rotate it with Control J. Okay, it doesn't work, so I will use the mirror technique. So I'll go to Edit, Mirror and Up Down. Yes, it did work. Now use the open polygon again. Edit, Modes, Edit, Toggle Outline Edit. And just a small curve. Yes. Now what do you need? A circle. So we will put a circle. Properties. Make the size 1. Say. Apply. Oh, it's too small. Make it 1.5. Yes, big enough. Now it doesn't move. I want it right in front of this. So I will just say X position is 5.25, which did move it little away, but now when we move the box, it will be perfect and close. A, B, and you have A or B. Just select this end terminal, yes, and drag it in. Yes.